welcome to another video about the wonderful world of Latin and ancient Rome, where I'm trying to build Vitruvius's odometer described in De Architectura, Book 10, Chapter 9. And I decided to make these out of K'NEX, which are a great engineering building tool, and because they have gears. So this is the first odometer I built, and it really was an experiment in how to make it work. So there's a lot of attempts to force it together, and some of this was that I built the bottom half first and the top half next, and then what I tried to do was I didn't have this wheel with me when I was building it, so I needed to get access to those supplies and then force the two parts together, which is partly why when you look at parts there's a lot of sort of weird angles to it and angles that just don't really work well with K'NEX. There were a few things where I tried to be really faithful to Vitruvius's description. So he starts with a system where you have a large wheel and then one gear with one tooth. This one tooth, when it turns, is supposed to turn the next wheel. And as that turns, it turns a even larger wheel that has about 400 teeth. Obviously, I didn't do exactly that number due to the limitations of K'NEX, but it has one longer tooth that turns a drum. And then that drum is supposed to turn and release a stone into a container, and then the number of stones in this container counts how far you've gone based on the circumference of the wheel and the number of teeth on the gears. And this drum at the top was one of the hardest bits to design due to Vitruvius's limited description. There are a few problems that you've probably already noticed some of. The gears at the bottom don't line up perfectly, and so sometimes they skip with it. Also, I had to tape this part together so that when it rotates, it does not sort of spin this part, and it doesn't actually make connection with this gear. This gear also doesn't totally turn perfectly every time this goes. And then sometimes this longer sort of tooth of the wheel does not actually get that to go as well as it should. All right, let's test odometer number 1. And nothing happened. Partly because as it goes, the gears aren't always catching. Now, one of the things that has also been a problem as I've tested this before is these marbles like to fall off. So if we get this to move how it should, the marble goes in and then falls out of its catching basin, and then that sometimes is apparently jamming the stopping mechanism, but it doesn't always fall into our bucket, and then our bucket doesn't actually hold things. So with all of those problems in mind, I built odometer number 2 that tends to actually, turn and work more often. It is also a lot more sturdy. I tried to make sure that all of the issues with K'NEX of it being wobbly were avoided. I built all of it at once, and I sacrificed some of the historical authenticity to actually getting K'NEX to work. I opted for all wheels of the same size, so I couldn't have one tooth that was much longer because otherwise it's not going to work with these wheels. So I have these 2 smaller gears. Those together rotate based on the whole vehicle moving, and then that rotates this gear, which again rotates our big wheel. This big wheel still has our one big tooth. This lever needs a little bit of force to get it to work, which is why I tied it on. It turns and rotates a very similar contraption. that has that drum spinning at the top to release the marbles so that they fall down the chute and into the bucket. The bucket is much more secure. Marbles are less likely to fall out because it's more solid. The whole ramp for them to get in is also more solid. And there are walls that prevent the marbles from bouncing out at top. And this sort of door allows me to put the marbles right in there on their little places. It still uses the Rube Goldberg like wall to knock the marbles down into here, which does sort of depend on there being another marble behind it for it to actually work. And if you notice, this whole system's set up so that when it moves forward, it pulls that gear along and has the next bit sort of reset right at the center. This helps as much torque get that to turn as possible and actually release marbles. So this one I did not install a string to pull, so I'm pushing from behind. So you get to see all of the gears work a little bit better. And yet the marble fell, but the other one is still in there. There are a lot of lessons that I've learned from this. First of all, the starting choices you make can have large, sometimes unpredictable effects, like when I tried to shove two parts of two different contraptions together to form one. And on the second odometer, the width was always one blue connect length next to one white connect length, which was sort of limiting as I built, but ultimately worked out fine in the end. The second lesson is about gears. They require precision, torque, stability, lack of interference, so that they actually turn each other. They have enough force to turn each other, and they're stable enough that the gears aren't shifting around and stick in one spot so that they turn each other. And if they're turning, they can't be hitting other things so that they actually keep on turning. The other lessons are about engineering itself, that engineering and designing a machine come with constant trial and error, problem solving, and working towards improvement, even when you have directions. And these directions can conflict with how the materials actually work. This is partly because there's many types of directions, like Vitruvius's paragraphs and the pictures that they give you in Modern Connects or Lego sets. Each of these have their own benefits. Connects is designed for the materials, and Vitruvius is working to give people an idea of how to build, not how to actually do it precisely. So he relies on people who know how to make gears and put them together. Now, there's always room for improvement, and this project's no exception. The next part is still going to be to get something that works a little bit better here. Thank you.